What an epic beginning. That music just like had me going. Hello, everybody. Welcome to this special edition, this special show. I believe this is our 9th episode. Welcome to Build and Scale Agentic AI Apps with Amazon Aurora, multi-agent orchestration. So today we're going to be talking all about agentic workflows. We're going to be talking about Aurora, and we're going to be getting hands-on and deep into some really interesting agentic code. Here's what we're going to learn. If we are going to be learning, what it means to bring our agents into production at AWS. How do I host my production agents in AWS? All of these things, you're going to be learning what it means to productionize an agent, how to productionize an agent, and then take you on that journey, right? Like how to build locally, how to deploy. So if you're technical, this is going to help you bring all of that code that you have sitting on your laptop into AWS, have it scale, have it be production ready. And if you're non-technical, there's still a lot to learn too. You're going to learn all of the different tools that you need in order to think about this and scale it for your enterprise. I am joined here by two very subject matter experts in this realm, Aditya and Shayan. But first, let me introduce myself, and then we'll go there. My name is John Marciniak. I am a solutions architect at AWS. I am coming to you live from Chicago, and I'm a little bit curious. Shayan, why don't you go first? Who are you? What do you do? And where are you joining from?
Sure. Thanks, John. Thanks for having us. So, hi, everyone. Thanks for dialing in. I'm Shayan Sanyal. I'm a principal database specialist SA here at AWS, and I focus on everything Amazon Aurora. I am dialed in from a sunny 40 degrees New Jersey today, where we got a little bit of a sneak peek of a fake spring earlier in the week. It was a
Yeah.
really bad teaser. We're back to the dim sort of very dull cold again. So not pleasant, but looking forward to the weekend at least. So happy Friday.
Happy Friday. Yeah, we definitely also in Chicago had that false spring a couple
Yeah.
times. So definitely understand that. It is actually really windy in Chicago right now. We've got a wind advisory. It's about 40 mile an hour gusts. That's about 64 kilometers. So it's like I can feel my house shaking right now. Aditya, how about you? How's the weather where you're at?
Well, I am here in Dallas, Texas, where it's almost always sunny, and the spring has sprung here. So sorry about that, folks, but it's pretty good outside here. Nice, I want to say 70 degrees, sunny. So yeah, it's great to be here. And like I always say in one of these shows, I am the other Cheyenne because what he said, it's basically the exact same description. I am also here doing everything Aurora for the last 8 years. I'm also a principal database specialist solutions architect, and I'm literally on the same team as Cheyenne. So, we're kind of the same person. So, hello.
It's great. That's great. So we've got people all over the place chiming in. I've got some folks from New York. We've got some folks from LA. Be sure to chime in. Tell us where you're joining from. That helps us kind of orient ourselves. It's always cool to see all the different folks from all over the world. Jersey City. It's also very eerily Friday the 13th. I did not realize that
I
until now.
noticed that.
Okay,
Man,
so
Friday the 13th.
I thought my lights were flickering because of the wind, but it's actually got a little bit more spooky connotations, I think. We got folks from the UK. So great seeing all of you. Thank you so much for joining us. And I am super excited for what is in store for us for the next 56 minutes. I vote maybe we should, get on with it and start talking about some of this amazing content that we have. So let's talk a little bit about the why. Like I think we have like why do we want to utilize production agents, integrate that with Aurora. What are some of the things that we want to think about there?
Yeah, I mean, and I'm gonna let Cheyenne talk about Aurora. He always does a great job, and why Aurora is great for AI. But primarily, what we're looking at here is we see a lot of folks just build these agents very, very easily on their laptops using Jupyter notebooks and all of that. But sometimes we talk to customers all the time, and they wonder, like, how do I productionize this thing? Oh, what does it even mean to productionize agents, right? Like, we have had all of these workloads. We have web servers and we have database servers. We have all of that figured out. But how do you productionize agents? And um, for us, what that means is, how do you make sure that if you have your database like Aurora wired directly into your agents, how do you make sure that the access is secure, right? Not just everyone can access that database. How do you make sure that it's isolated? How do you make sure that it scales well using some of the serverless technologies? How do you add observability? How do you add auditability? Now, can you do all of that by yourself? Of course you can, right? It's a lot of work. And hopefully, what we would like to show you, do a little bit of show and tell. And I apologize in advance. There will be a few slides, right? Only a few, but mostly code walkthroughs and that kind of good stuff, and demos, some really cool demos. And we're gonna kind of take you on a journey where we'll show you kind of an existing non-agentic app, and then we'll show you how we can build local agents, productionize those agents, and then put it so that this old legacy app becomes an agentic app. It's going to be fun. Shayan, I know you want to talk all about the Aurora piece, please.
Yeah, no, thank you, Aditya, for setting that up. I think it's pretty much like a no-brainer. Everyone wants to get into this race of agentifying their apps these days, but there's really no like production use cases that we see as often as these demos, right? So I think that's where we are looking at sort of customers who are building already on Aurora. So you have your traditional legacy apps sitting on top of Aurora. You do things like customer data analysis, you do customer billing management, you track their usage over time, etc. So there's a lot of existing sort of rich data sitting in these databases with Aurora. But then the question that I get is, how do I like agentify this? How do I put the same operational best practices that I've spent years and years tuning my database to this agentic whole new paradigm shift? So that's where kind of we dive a little bit deeper today in our session on Aurora for AI. And the benefit is you do have specialized sort of data types within Aurora to support a lot of this newer Gen AI/agentic workloads, starting with search, which is where Aurora introduces this PG vector extension, which is used to do semantic search, similarity search, etc., to build your search use cases. There's also the MCP server, which we'll dive into much deeper later in the session, where the common sort of SQL query, even though it's a very simple query, to me as a developer, sometimes it's a little bit, it takes a couple of steps to get down to the actual query semantics. I have to make sure that the syntax works. I have to make sure that I can easily go and look at all the tables. Maybe there are like 10 different tables. Maybe there are a million tables. So we make it a little bit easier with the MCP server there. And we'll talk a lot about all of those things later in the session. So Aurora does give you these this operational sort of pillar on top of your existing stack, and then you sort of have these components like PG Vector and MCP, which simplify a lot of this agentic app building.
Yeah, and that actually builds up to a really good question that Louis is asking. But how
Which
we can
one?
actually the first one, I don't know if you can flash it here on the screen, but he's asking, well, how can this actually help us and unlock some of the enterprise use cases, right? And I think this is something that we're gonna show today is if you have these applications that are already hardwired into Aurora, wouldn't it be amazing if you can ask questions to these applications instead of having to click through everything? I think that's the opportunity. Is like, I have a legacy application. How do I agentify it? How do I add chatbots? How do I ask questions? I think that's kind of the whole point here.
Love it. Yeah, there's Louis is actually dropping a lot of really good questions in this chat, so I'm sure we'll pull up a few others along the way. Where should we start next? I know that you mentioned we have some slides. Do we want to start getting into the workshop and showing some code? What's
Yeah,
next?
I think what we can do, and I think Cheyenne is going to kick off that journey there, where we'll show you what we have. Right, we'll start with a energy application, which is non-agentic, and then we'll show you how we can start building some of that functionality that is clicked through today into agents. So over to you, Cheyenne.
Yeah. So I will bring up my screen real quick here and we'll look at where we are. So typically the journey is the thinking at least behind this is, oh, this whole agentic, like everyone is trying to build these agentic applications. Where do I start? Like, do I have to drop everything, start from scratch? No, right? So the simple answer is no. We do help you meet where you are. So this is exactly the architecture. Imagine we are working today with a fictional energy utility company called Electrify. And this is the architecture, which is a legacy kind of an architecture. It's a monolith. Everyone starts here. You're not behind. Everyone, in fact, starts even a step behind where you're either on mainframe or like some legacy database. So here we are a little bit forward. We are using cloud-based services. We are still on a little bit of a modernized journey with the serverless stack. So we use our users come in and sort of look at this static website hosted behind S3 and CloudFront, and they access it using an Amazon API gateway endpoint. That again, in the behind the scenes, it's going and calling these Lambda functions. The Lambda is querying our databases and fetching these results for you to basically render a static website. This is our architecture. So we are using pretty much all native services with all the serverless stack. So API gateway for a whole bunch of things like get devices, get billing data, get providers, get customers, etc. And Aurora also is serverless, so you don't have to actually have instances managing your clusters now. Aurora serverless comes with instances that you don't have to manage. It's an on-demand auto-scaling option to get very quickly started with your workloads. This is what it looks like. This is literally like I'll zoom in a little bit here. A static website, fairly like simple. We basically look at our account usage. This is our billing electricity bill. We have a dashboard. We have some usage data, probably like usage over the past 12 months, top consumers this month, top consumers over the past 12 months, and so on. And then there's some billing data that we can download. Pretty simple static website. This is typically where we begin. But then what we are going to do is by way of a lot of these agentic frameworks and sort of agentifying this mainframe legacy app, we are going to go into the agentic architecture. So previously in the legacy world, we are really tied to these fixed one path, single shot sort of routes, right? There's a fixed REST API endpoint. There's a fixed contract that the REST API follows in a predetermined set of steps that it has to always follow. Agentic, in the agentic world, it's a little bit non-deterministic. So there is no set path. There could be multiple paths. And that's where we kind of look at this whole domain specialist concept, which is where we look at specialized agents, which do one thing and they do that one thing really well. So in our demo today, we'll have the Electrify agent that is sort of our database specialist that runs queries against our Aurora database. And we are actually lifting and shifting the same stack. So getting billing data, getting user query, customer data, getting rates, etc. All of those are literally now sitting behind this modernized architecture. We'll go much deeper into the architecture later. But then it's doing the same thing. We are still calling the same functions that we have written using those specialist agents. And then now, but for the fact that we have these multiple specialist agents, we can actually have a orchestrator or a supervisor to delegate. You can think of it as a traffic cop. You're basically delegating certain sections of the traffic to certain lanes just to avoid congestion. It's the simplest way to think about it. So in our demo today, we'll have an Electrify agent, which will do database specific things, the API calls and the Lambda functions that we wrote previously. And then there's just a little bit of a charting analysis agent. We call it the data visualization agent, which helps us visualize where our bills are getting spent, right? What our billing is, what's the usage, etc. Take a quick pause there. Yeah.
That was very I think well done and very comprehensive of I think everything that you think about when you're taking an app to production and how it's going to integrate and interact with all of these different services. I did want to back up. We did have one comment that I thought we should probably talk about, and this one comes from Reginaldo. When does a cloud architect use Aurora, an Aurora cluster over a similar RDS? I could choose, Postgres with vector plugins and things like that. Like, what are the different options? Why Aurora specifically?
Yeah, so it's a great question, Reginaldo. So the way we think about it, and you'll actually, if you're following the journey, even at AWS for these different purpose-built databases, you'll notice that we've been sort of since January, I believe, we have been hosting these, even within these live streams, different engines with vector search capabilities. So the goal is to have vector search as sort of a primitive across the stack, across all our managed database services. And then we also have the MCP server and the agent code that is agnostic of anything under the hoods. So you can still use Postgres, you can use MySQL, you can use any version of database of your choice. You can use even non-relational like DynamoDB. But here, Aurora gives you the operational advantages, right? So you have fast failovers, you have clones, you have serverless v2 if you want to scale down to absolute zero against RDS. That this is now just RDS Postgres versus Aurora Postgres. So RDS and Aurora again both support fully Postgres compatible. They both support the PG vector extension. But then there are capabilities like global database. There is storage auto scaling. So you don't have to manage the capacity for provisioning or pre-provisioning your EBS volumes anymore with Aurora. It auto scales. And then serverless will auto scale down to complete zero, which is if you're pausing your workloads, there is a spiky workload. And typically your agents will actually have very bursty query patterns. So serverless v2 is particularly useful because it can scale down to absolute zero and save you a lot of costs. But this architecture pattern itself could be used across the stack, all databases.
Sounds good. So should we get on to with our demos then?
Yeah, let's get started. I think, are we going to start with developing local agents? Like, are we going to?
Yes. So just to get started, so we are going to take you through this journey here, right? So we saw what we're building towards. The end goal is to take that legacy app to this modern agentic app. And we are obviously going to scale it, productionize it, and all of that good stuff. So the first part of this, which I'll cover, is building these locally. And this is probably what you're also doing right now as we speak. We have a lot of Jupyter notebooks being used across the board. For our demo today, we are again looking at the Electrify web app. And we are going to build a couple of agents. Electrify agent is one, and the database agent is the other one. And then we are going to sort of deploy these locally, ask some questions, play around with it, and then we'll scale it to production, which is the later half, which Aditya will take us through. All right, so in this case, I'll go back here for a little bit. I'll just minimize this terminal for a little bit. Anytime you're in your mind, like whenever you're starting out, the first question is, how can I get started very easily? What's the first thing I need to do? What does Aurora give me to get started super quickly? And the first thing is the MCP server. So within a AWS Labs central GitHub page, we have a whole bunch of MCP servers. And within this, we have the Postgres MCP server. So this server is already pre-installed, pre-set up on my laptop. But then this the benefit there is anytime you want to do schema discovery, anytime you want to do a simple run select query, read only queries, we have wrappers around those queries. So we call these functions, or in MCP lingo, we call these MCP tools that are available for you to literally query the database in natural language. So what I'm going to do here is a little bit of a copy paste of my code. Here, I'm going to just run this, kick this off. So this, basically what it does is initiate my Postgres MCP server locally. So I have installed it prior to this demo. Obviously, it takes a few seconds. But then you'll notice this MCP server has the read-only flag true, which is right here. I have my similar credentials to connect to the cluster. It's pretty much the same ARN that you see anytime you're connecting. The couple of nice tools here are run query and get table schema. So this is your schema exploration, schema discovery tool. And what this does is now basically we have deployed this mini agent that can call this MCP server, and you can start exploring the database itself. The agent code is pretty much simple. It's a boilerplate code. We'll share all this post the demo today. But let's start asking some basic questions. I'll just ask a simple question. Describe this Postgres database and its tables. Let's start with a very simple example. So it'll do its thing. It'll sort of do the schema translation. It'll convert that simple, pure natural language question back into a SQL query, which is what it's doing right now. You'll see this whole complicated query. Even to a DBA expert at this point, I would mention that writing this query is also not straightforward, right? If you're coming from a background which you are still an expert, you still don't know what tables there are, you still don't know what columns there are. So there's a little bit of ramp up time that you need to get up to speed before you write this query. All right. So our agent went in, invoked that MCP call, used the tool, and then we are able to see this in a nice formatted way. The database appears to be an energy utility company that manages customer billing, yada, yada, yada. And then we have customers table, we have devices, we have 13 different tables. But this gives you a good sort of lay of the land. I know what my tables are, I know what my schema is, and I can start like poking around a little bit.
But this is, I just wanted to call this out, right, Chan? Like, this is so cool where none of this is scripted, right? Like, we aren't like injecting any prompts or anything. We just asked a simple question like, what can you tell me about this database? And it goes, oh, this is a electricity utility database. And it's able to discover it all by itself. So the LLM in the backend is doing all this translation for you. So imagine you are a DBA or you're trying to figure out, well, I have to manage this database now. What is this database even about? You can ask those questions in simple language and get these beautiful answers.
Exactly.
I don't think we had anything like this before in the past. I used to be a DBA for a long, long time. And you just had to go to like these documents and pour through documents and figure out what you're even dealing with.
Yeah. Exactly the point. We are like the whole point of, and for those who are not familiar, I hope everyone is now familiar with MCP. It's basically a drop-in replacement for your REST API contract, right? You're essentially exposing these tools, exposing these functions, which are nothing but wrappers around your SQL scripts. You can have shell scripts, you can have bash, and these are nothing but your select star from blah, blah, blah. And it's an easy way and a unified, more consistent way that you expose these tools to your agents via the MCP.
Yeah, and Aditya, I was thinking the same thing. Like, I don't think these tools could have existed in the past, even with like traditional machine learning models, because it would have to be trained on very specific things. And I think the advent of these large language models just makes it so accessible to learn and understand and translate back into natural language. So I agree. This is really amazing stuff, and the jumping from insights to knowledge is just amazing these days.
Yeah, I mean, it was not possible, like physically impossible back then. We just didn't have the compute power back then. So now that kind of compute power is like on my M4 laptop, which didn't exist in servers before.
Right.
Anyway, sorry, Cheyenne, back to you.
No worries. All good. So what we just saw was more like a commodity, right? So we just talked about this compute. It's essentially a commodity. And this generalized Aurora Postgres MCP server or any XYZ, drop your favorite MCP server there, is more of a generic like replacement for everything. You can run any select query via the run query. You can get any schema. You basically do describe tables. You can get any schema information using the get schema, table schema tool. But then usually as you are building towards production, you're looking at more specialized purpose-built tools to do certain things. And always there's going to be guardrails. You don't want to do write queries. You don't want to do updates via the agent because it can just go haywire, do wonky stuff that you obviously don't want in your database. So in the next phase of the demo, what we'll do is we'll start look at our Electrify agent, who will use these custom tools. And I'll just take a little bit of a segue here. So this is a workshop. We will share the code and the sort of the manual for this workshop post the session.
Oh,
But
it's shared already. Just
yeah,
FYI.
Yeah,
awesome.
it's shared.
So
So if
creating
you
your first agent is actually like super quick. Oh, sorry, John, you were saying
No, I
something.
was just gonna public service announcement. If you're looking for the link to this, it is in the chat. Whether you're on Twitch or on YouTube, look for a producer Jeff AWS or from the AWS Events channel itself. There you go. Yep, there it is.
Perfect.
So, sorry, just wanted to interrupt with that.
Oh, this is great. I mean, everything that we're showing here today, you should be able to just go back and do it yourself
Exactly.
because it's all public. All the code is public. So
Yep.
have fun.
Right. So creating your first agent. So this is our Electrify agent, and I just want to quickly cover the flow. It's super easy, and this is actually what we'll follow throughout. Anytime your user comes in, and that's me in this case, and I ask a question in natural language, you can have an agentic framework sitting in the middle between your database and the user, right? So this is the stack that we are actually replacing with our legacy stack. This agentic framework could be Strands SDK, it could be LangGraph, it could be any of your favorite agentic framework, doesn't matter. For this workshop, we are using LangGraph just to give you a sense of like how things will work. But then LangGraph translates that query and it goes to this language model. And then the language model essentially is the brain, right? It's reasoning about user queries. It has access to the LLM. It decides which tools to use to answer that query, goes to the MCP server. The MCP server again registers its tools and lists those out. So, hey, here is the list of tools that I have. Use these for your query. And then it executes, using those tools, it executes the query against the database, returns the results back to the user. So this is sort of the high level architecture. But even for this, remember, now we're talking about custom MCP servers. We use the Aurora Postgres for some generic schema exploration. Now, for this demo, we have written 3 custom functions. Remember, again, MCP tools are nothing but functions that get wrapped in an MCP server that are invoked by the agent. That's the whole flow. So get rates, get customers, get bills. These are our 3 custom functions or custom tools that we are writing for our Electrify agent, which is our first agent. All right. So obviously, just in the interest of time, we've sort of pre-written the code already. It's all there in the workshop. But I'm going to start executing the code. So it's my agent in module 2. And I'm going to start sort of invoking this. So you'll see this is ready to go. This is my mini LangGraph agent. This is, again, these agentic frameworks are based on something called React, which is nothing but reason and act. They constantly sort of reason about the thought process, their sort of chain of thought, and then act on decisions. So they're going a little bit beyond what traditional LLMs used to do. And then I'm going to start asking my questions. So let me ask, what are the available rate plans, for example? Now remember, this what are the available rate plans question isn't simply answerable by a run query with the Postgres MCP or get table schema or any other pre-canned tools. Hence, always when you're productionizing these agentic apps, you need some custom sort of flavors, custom schema, discovery, custom tools that you will require for your use cases. So now in this case, what we did, I'll go back here. What are the available rate plans? This was my question. So here I will see in the agent trace, obviously this is the backend view. I'm seeing a tool called, which is get rates with certain arguments. And this get rates function, if I just go here in module 2 in the server side, it's basically pre-written here. So get rates, get customer, get bills. This is my tool implementation, which is nothing but a SQL query, right? So this is the query that we are invoking via the agent, via our custom MCP server. And then we get a pretty nice sort of, you can always format this in a nice UI, which is what we'll see later. But this is basically the response. So you have a flat rate, you have a solar saver plan, you have some other plans, etc.
And so, just so I think we kind of broadly understand, those individual tools contain basically like the framework code that help put together the call to the database and what it's getting based on what that tool is supposed to be doing, right?
Exactly. Exactly. Yeah, there's going to be a server, sort of MCP server that you define, which will have the tool implementations. And then there's going to be the agent that actually invokes those tools via the MCP server. And this is pretty boilerplate. This is, you can use, for LangGraph, we use the decorator, a specific decorator with ampersand wrap model call. With strands, we use a different decorator. So depending on the agentic framework, all you'll have is a different decorator. With strands, it's a little simpler. It's at the rate tool. You just basically decorate the function with at tool, and that exposes those MCP tools to your agent as custom tools that your databases can now act on.
Yeah, and I'm glad you're talking about strands. We do have a roadmap to actually add strands to this workshop also. But what I've noticed is strands just makes things so much easier for you. It's kudos to our AWS developers who kind of thought through all of these things, and instead of having to like really put in coding effort, you just do like add tool and you're good to go.
Exactly.
So strands really makes life much easier when you're doing these things. Of course, you can use any tool of your or any framework of your choice, which we're using here, which is LangGraph and LangChain. LangGraph, LangChain, I think, gives you a lot more control and granularity on everything that you want to do. And eventually, what you'll see is that regardless of what framework you chose, the agent core that we will talk in a bit works with everything, right? Which is what we want. We want an open platform.
Right. Yep. Yeah, and I think there's certain use cases for different frameworks, just like there's certain use cases for different models. It's all about choosing the right thing for the right implementation, whether it's a model or a framework, or just what you're comfortable with. So
yeah, and
definitely.
as you get advanced, you could use one model for, let's say, the orchestrator agent, and then use another framework for the MCPs that are sitting behind your MCP server. So you can mix and match. Agent core doesn't care. It's gonna agentify and productionize it nevertheless.
Yep. True words. So, all right. So we did look at our first agent. So it was super simple. I hope it was easy to understand. And I'm going to go back here for a little bit. Similarly, we created our Electrify agent, which can now answer questions like get me some available rate plans, show me my recent bills, etc., using those three custom tools. Now, the other thing is, similarly, you can actually have different agents do certain different things. And why we do that is essentially anytime your agents go past a certain number of tools, you can obviously go you will ask a question that, hey, where do I stop? Like, how many do I keep creating more and more tools? Do I keep creating, adding more and more MCP servers? So, where is that fine line? So typically what we've seen in the field is anytime you get past that 10 to 15 sweet spot, it's this 10 to 15 number, your agent starts hallucinating because it has to make more decisioning. It has to take more decisions, make more tool calls, do more tool chaining. And usually what happens is the output from the previous step as an input to the next step, there will be some sort of failure between. It's not always 100% right. So your accuracy at the end of the day will drop. So instead, what we do is create these separate domain specialists with limited number of tools, 3 to 5 per MCP server, 3 to 5 per agent. And here, that's exactly what we are doing, right? So your agent doesn't actually hallucinate. You have sort of a traffic router or a traffic cop that can route to specialist agents and do it more perfectly for that use case. So here we have a data visualization agent, which is essentially going to just create these charts, really nice charts for our billing data. So essentially what you saw here or the usage data, this is exactly what we also need in our modern app, if not more functionalities. So we have our data viz agent, and we'll go back here. I'll yeah, actually, we will skip this just in the interest of time. We are we have a lot to show and tell today. So we'll jump to the supervisor, and the supervisor is your traffic cop. This is the orchestrator, which will delegate traffic to either the Electrify agent, depending on the question, or the data visualization, or combine both, because I can ask a question that combines both of those and chain both of those tool calls. So the orchestrator is very similar. We'll go back to our console here, minimize this editor. I'll pull up the orchestrator agent code. And then here you'll see, zoom in a little bit. There is a pretty nice sort of system prompt. And the system prompt is nothing but, again, in plain simple English, a set of instructions which we are telling the agent to follow step by step. It's the contract that it has to follow to do certain things, to make certain tool calls, to have certain tone in their language while answering the question, like helpful, etc. And that's the system prompt. So we have a data visualization agent, which will create charts, which we'll have an electrify agent, which will retrieve data from our database using those custom tools. What is your role? This is my role. You will analyze the user request. While chaining operations, use this step or sequence of operations, and then present it to the user in a nice, readable, friendly way. So we are going to dive into the orchestrator example here again. And notice that I am just using something called UV here. UV is, if you're not familiar, it's just a simple way to run these commands. It's a package, Python package manager, which is just you're passing these bunch of arguments and you're just running this very easily with this package manager. So I invoked the orchestrator agent. It can now answer questions that combine one or the other or both. So what I'll do here is ask a question that actually combines both. Can you plot a pie chart of my last 6-month bills? So it's going to do its magic. It's going to go and invoke a bunch of tools. And it's going to take a little bit. While we get there, we can have a few more questions.
One of the things that I wanted to really quickly talk about, Cheyenne, is this specific pattern that you talked about, right? Like the orchestrator and supervisor pattern. Now, in this case, again, this is the art of the possible. So we didn't really have to, we could have just basically said, we have a flat model and the agent has all these 4 or 5 tools. That would have been absolutely fine. But in production use cases, this is not going to scale, right? So in the workshop, there is actually a more, like, if you want to do a deep dive, there's optional reading section that actually explores all of these potential options, right? Like, so here's the pattern that we built. But if you wanted to build other patterns, if you scroll down, Chan, you would see that we are also exploring alternative, like the flat architecture, a flat architecture with semantic search. So we are also exploring other potential options that you could have implemented.
Yeah, and in this case, like what you'll also see is Agent Core does provide this semantic search tool, because you can easily get into this 1,000 sort of too many tools problem. So there, what you do is with Agent Core, you can actually semantically search a few handful tools, so you don't rot your context window, and just load those tools during runtime in the session memory for the agent, and just invoke those tools so that you don't sort of overspill. Before you're even able to get to the question, you are rotting your context window and overfilling it and sort of overloading it.
Yeah.
All right.
Go ahead.
So let's go back. So I'm going to ask a question. So I already asked my question. So here is the response. Perfect. I've created a pie chart of your last 6 months of electricity bills. Here's what the visualization shows. So what I'll do is quickly show you. So it had two chained tool calls. So first was I needed to get the last 6-month bill. So here what I did was basically invoke this tool, MCP server, with parameters get bills. This was the tool that was called. I got my bills for the last 6 months, and then I need to create a pie chart. So I'm now chaining the input from the previous step down to the next step, which is my data viz agent. And I'm going to create this chart right here. So if I go to the charts dashboard, open up this pie chart, it creates this nice little chart over the last 6 months on where the majority of my data distribution has been. Right. So looks like it's pretty consistent, but that's not what my electricity company tells me, unfortunately. But this is your orchestrator agent in action.
Yeah.
Right? Yeah.
Just really quick, I saw, we've got a few more people joining as we continue. We like to see that. Thanks. I just want to say thanks for joining. This is Build and Scale Agentic AI Apps. What we're doing here is we're starting with a development local app, and we're learning what it means to productionize an agent and how to build locally, how to deploy, and how to scale. Sorry, I just wanted to interrupt and just kind of welcome our new guests and kind of do that PSA really quick.
Absolutely. No, you're all good. I think so. This is a good sort of stopping point. So we've seen sort of a lot of the stuff that we do today locally, and this all works great. You're able to trace the agent steps. You're able to see in the background, for example, in the terminal here. I was able to see what is the chain of thought, what tools it's calling, what's the SQL server, what's the SQL statement it's executing. A lot of that good stuff is already here, but it's not in CloudWatch. It's not in my production infrastructure. So let's fix that. So in the next section, Aditya will take you over on how to productionize this whole architecture with Agent Core. Aditya, over to you.
Awesome. Let's do that. Can we get my screen up?
Yeah, let's do that. There we go.
All right. So I'm just going to do a quick kind of a rehash of what Cheyenne has already been building, right? So if you remember, this is what Cheyenne showed us. He built this multi-agent orchestration. We have our supervisor agent. Again, all of this running locally. Then we created the Electrify agent, which is able to go and take user-related questions like, what was my utilization? What are my bills looking like? And then we have this database agent, right, which is creating those pie charts, etc. And they have their own tools. This is all great, but again, this is all running locally. So what we want to do is we want to deploy it into AWS. We want to productionize it, right? That's the question that we started out with, like, what does that even mean? And the tool of choice in AWS to do exactly that is Bedrock Agent Core. So Bedrock Agent Core essentially allows you to deploy these agents that you built locally into AWS. And then once you do that, you get all of this really nice instrumentation that's built in. So you get ability to enforce policies, you get observability, you get short-term, long-term memory, and many, many more, right? So Agent Core is not a single service. It's like an umbrella service, and it has a lot of really nice productionized tools built in. We're not going to use all of them today. That would be a day-long thing kind of that we'll have to walk through. But we will use runtime and Agent Core runtime and Agent Core gateway. So we'll look at that. So again, I just want to quickly go back to our old architecture. This is our existing architecture. And you'll see that there are all of these lambdas that are going to database. We are using like API calls, etc. So we're not going to destroy all of this, right? What we're going to do is we are going to complement it by adding the Agent Core piece to it. So essentially what we're going to do is we will keep some of that old stuff or almost all of that old stuff intact, but we will add a chatbot. And the way we're going to do that is by adding these two main services. So that, remember that orchestrator, the traffic cop that Cheyenne was talking about, that goes into Agent Core runtime. And then the other two agents that we had before, the database agent and the Electrify agent, that's going to go behind the Agent Core gateway. So don't worry about it. We're going to talk about exactly what that means, and I'm going to show you some demos. Hopefully that makes sense. So from here on, what I'll do is I am going to just start showing you some of these demos. So the first thing, and again, I'm doing all of this live, guys. So Cheyenne, please start chanting those prayers to the demo gods. And in case something goes wrong, we'll probably have to swap the screen. So just please be ready with that. Hopefully, we don't have to do any of that. Anyway, so the first thing we're going to do is we are going to first deploy these two agents, the database agent and the Electrify agent, beyond the Agent Core gateway. So before we start doing that, I did want to talk a little bit about Agent Core gateway. So what Agent Core gateway does is it gives you a unified HTTPS endpoint that exposes literally anything that you put behind it. So in this case, we are going to take our agents and we are going to package it into Lambda. We are going to deploy that behind this gateway, and they get exposed as MCP servers. But you don't have to only expose Lambdas. You could expose like your REST API. You could expose Open API. So there are lots of choices. So you could technically take all of these APIs that you already had in your application and put them behind Agent Core Gateway, and they suddenly become callable MCP tools. How cool is that, right? So let me start kind of walking through some of these things. So I'm going to literally start deploying this live here. So the first things first, I am going to deploy our first Lambda. So remember the Electrify agent that Shine was talking about? What we're doing is we're essentially taking that code, and if you see, all of that code is right here under this module. We take that code, we package it up, and then we deploy it in Lambda. So now suddenly that code that was living locally is now serverless Lambda that's running here. So I'm going to go ahead and grab that inside a parameter so that we can use it later, or environment variables. So that's one agent done. Now we are going to take our second agent. This is our database agent. And now I'm going to deploy it in the Lambda as well. So again, we are taking that local code, we're just packaging it up and putting it into Lambda. Now, as you see, it is also building IAM roles. It is also packaging dependencies, right? So this is what we were talking about before. All of this stuff was living locally on your laptop or in your Jupyter notebook or what have you before. Now, all of this is getting essentially productionized, right in front of your eyes. So same code, maybe a little bit of scaffolding here and there, but it's getting productionized. Now, what I'm going to do next is I'm going to take these two Lambdas and I'm going to deploy them behind the, let me just clear my screen here, and I'm going to put them behind the gateway. So this deploy simple gateway, if you see, it takes two parameters. So it's going to take the Electrify Lambda ARN, and it's also going to take the Database Lambda ARN, and it is not open, right? So this gateway, again, we're talking about productionizing here, which means that we want to authenticate everything. So the way we're authenticating is by using a Cognito. So we are using Cognito as our authentication provider here. So we have already pre-created the Cognito pool and client ID, et cetera, et cetera. So there it is. So now our gateway is already deployed. I mean, I don't know, I've been talking less than 5 minutes and it's already productionized, right? Yeah. So there we go. So now I'm going to show you how you can actually use some of these tools. Now that it has been productionized and behind the gateway, let me show you how we can use it. But before we use these tools, first, we have to actually pass a token, right? I told you, like, this is not an open gateway. Not anyone can get to it. So essentially, I have to generate a token first. So here I'm generating the token. And then I'm going to pass this token. And let's kind of look at what this gateway even offers us. So if you see here, what I did was I basically, I'm testing this gateway. There's a Python script that's just basically making a call to this HTTPS gateway URL that I talked about. And I pass a token, right? Now it processed all that token, authenticated itself. And now look at this. It found 9 tools. Remember all the tools that Cheyenne was talking about that were local? Now they're productionized. Now they're behind the gateway. So we have all our database server functions behind the gateway, and then also the Electrify server functions. So all of these tools are nicely discoverable behind Agent Core Gateway. And now the others. Sorry, go ahead.
Sorry, I just want to say, like, that's a really huge thing right now. It's productionized, meaning now you're utilizing all of the benefits of the cloud, the scalability. These are Lambda functions or ECS containers? Which one?
These are Lambda functions, but you could have ECS containers if you wanted to.
Yeah,
right. We're open.
You can start using this at production with production traffic, and it's going to scale. And I think that's really huge. It was in just a few minutes, like that. If we have time,
serverless, right?
Serverless, exactly. If we do have time for one question, it doesn't have to be right now, but we've got one queued up.
While Aditya is running, maybe I can answer that question. While Aditya, you are running the.
So
we're going to run out of time. So we have like barely 11 minutes. I want to make sure that I want to cover everything, right? Yep. So the one thing that I did want to talk about is, Cheyenne, what you were saying before, the semantic search tool, right? So if you see here, the semantic search tool is in addition to all these tools that we deploy. So this is packaged. This is part of the gateway service. So what the semantic tool does is that when anything that is interacting with the gateway. The gateway kind of shows up like a giant MCP server, right? But you can ask simple questions, and the semantic matching tool will find the right tool for you. That's how you avoid that context rot or the hallucinations that Cheyenne was talking about before. So that's what makes things super easy for you. So I'm not going to do a lot of testing, but I did want to make a quick individual tool call instead of just listing the tools. So if you see here, what we're saying is, don't just list the tools. Actually use this specific tool, the electrify server function, get bills. So what I'm saying is, for this customer, get me the last 5 bills, right? So it went ahead and now it's making that tool call specifically. Now, this kind of looks like gibberish, but we will format it nicely when we look at the app. And now you can kind of see that it made the tool call, it went to the database, it got the right information, making sure that it only allows the authenticated users, which is this RO at example.com user in this case, okay? All right. The next we are going to do is we are going to start using runtime. So these two tools are now behind this Agent Core Gateway. They're nicely available as callable MCP tools, but we still need that orchestrator, right? Remember that orchestrator we talked about? So what we're going to do is we are going to take that orchestrator code and we are going to deploy it into Agent Core runtime. Now, before we do that, we have to configure the Agent Core runtime. And that's what I'm doing here. So it got configured. It gets configured real quick, but the deployment actually takes a while. So I'm going to start deploying it and we'll take some questions. So if you see, it actually configured everything. It's using a custom JWT authorizer, which is the Cognito in this case. And now I'm going to deploy this thing. Now, when we start deploying it, you would see that it starts launching the Agent Core. It's going to create the memory resources. This is going to go on for a while. So good time for questions.
Great,
go ahead,
great. I think we probably have time for one before
Sure.
we have to wrap up here and then wrap up the show. And it came from Reginaldo again. It's a good one. It goes back to the gateway and the tools. What if I need to have tons of tools? Should I have multiple levels of orchestration, like agent to MCP tool? I think
it's totally up to you. It's totally up to you. You have the ability, and this is the advanced reading that I was talking about before, right? In this case, what we've done is we have chosen a model of agents as tools, right? So what's going to happen in this case is the orchestrator agent talks to the MCP gateway, and then it calls a tool, which is actually an agent. So it has its own LLM loop, and then it has the ability to use its custom domain knowledge to call the right tool that has available to itself. You don't have to do that. You can basically just create all the tools and expose it behind the gateway, and then use gateway semantic abilities to ask for simple questions, and then using the right tool. These permutations and combinations depend on your use case, how much scale you want, what is, if you really need specific domain-specific agents, or you just have some nice list of tools. Now, you could have these domain-specific agents, and then you can also have generic MCP servers that are already exposed, like the Postgres MCP server that Cheyenne was talking about before. You can expose that behind MCP, the Agent Core Gateway as well, right? The choice is kind of unlimited, and that's kind of the whole point of this open framework or open service that allows you to do all of these permutations and combinations.
Do remember, I will call out,
Yeah.
I will call out like a trade-off. Do remember, like as you're getting into this tens of thousands of tools, each hop, if you're doing it like DIY style, your own sort of self-managed, each hop will add latency. So an extra LLM will have another routing decision. Deeper nesting will make debugging even harder. So if you need like managed good observability across the stack, it'll be harder to trace the chain. And then your context can get lost across those hops, right? So this is where Agent Core is simplifying all of this a little bit better. You're able to operationalize the whole stack with one view into the observability stack. What is the chain of thought? What is the decisioning that the agent is taking? There are traces. And for most real world use cases, the pattern that Aditya was referring to, the agents as tools 2 levels of those, so orchestrator calling specialist agents to their tools is the sweet spot. 3 levels is doable, but you really need to justify the complexity, right, and manage that complexity.
Yeah, that's true. Totally.
Exactly.
Great. How are we
All right.
looking? It looks like we're just
We're
about to finish
almost
up.
done, and so essentially, I did want to talk about what this like. This looks like kind of my 8-year-old calls oh, you're hacking away. So she thinks that I sit here and hack other people's accounts all day, which is obviously not true. But essentially, I did want to say like what is going on here is if you see that all of this code that Cheyenne was showing you before, like all of that local code, it's all here. But we have also created this runtime adapter. This runtime adapter basically just takes all of those agents, the Electrify agent, etc., and it wraps it. It adds all the scaffolding that is needed for it to deploy it into Agent Core. Now, we have like 4 minutes left, so I'm going to skip all the description. But do take a look at this workshop. The workshop goes super deep into the code. It describes every little thing. It goes, line by line, describes all the code. So it should be, fairly easy to understand. So the next thing that I wanted to do is a really super quick, all this deployed code. I did want to do a quick test, right? Oops, sorry. So I'm going to, again, I have to generate a fresh new token. And let's get that token here. And now do a quick test using this deployed agent. So now if you see here, now we're not making any local calls. The calls are going to this endpoint. So, and the agent is exposed behind this endpoint. So I'm asking the same question, what rate plans are available? But this time we are using the token and we are not doing it locally. We are doing it using this endpoint, right? So now you would see that we're starting to get that streaming response. It is selecting the appropriate tool. And then again, it's giving the exact same answers, but this is now all productionized. It's all secure. You're getting, isolated sessions per user, and your database is sitting securely behind Agent Core, kind of you can just think of like a firewall. So that's kind of takes you all the way from writing these tools locally, going all the way and productionizing it. I do want to, hopefully we have a few more minutes. So I do want to show the actual productionized version of this app. So what I'm going to do is I'm going to take the UI and I'm going to recompile it. And hopefully it will come back in time. And I'm just going to, once that gets deployed, I'm going to refresh this. And hopefully you should see a chatbot here. So if you have a couple of questions until this kind of refreshes or compiles, let's go for it. Race against the time, guys.
Yeah, I think this is a good time to once again plug that workshop. We do have that link in the chat. This is a really great workshop, and we're only touching a piece of it, right? So there's a lot of other functionality that we can utilize into this as well. So thanks so much so far for all these awesome questions. Thanks for your engagement. And I am really just kind of eating time away to
you are. I'm really dying to ask this question. Are we ready to see the chatbot? Are we ready?
Drum roll, yes. Drum roll, yes.
All right, here we go. Refresh.
There we go.
There we go. There's our chatbot. So the same app that was that's now all agentic. I can ask questions like "Hello," and it's gonna go into that beautiful little thinking mode, and it's hopefully it should come back and give us some answers. And I do want to leave everything with a nice chart. So hopefully we will have enough time to just ask one more question.
We can ask one more question.
Here we go. Here's the chart question. Go for it. All right. So while that processes, if you have a question, we can ask. But again, thank you all for being with us here. Hopefully everyone enjoyed it. And there we go. The billing history is showing up on the screen. And in a second, we'll see a nice, pretty little chart that we have been developing throughout this workshop.
So great. And the chat is going wild right now. We've got producers happy. We've got some folks on Twitch that are super happy with it. It's been a great experience. I think like really taking it from the code on my laptop to, let's test it out locally to in just a matter of minutes, deployed this up into the cloud, and then within the hour, literally, we've deployed this, and we have it working in our app, and it's creating calls. It's going to the database. It's going back. We really have shown going all of the value from going from laptop code all the way to production. I want to thank you guys so much, Aditya and Shyam, for your time, your expertise over the past hour. I want to thank everybody else in the chat for joining, and I think this is where we say goodbye.
Thank you, folks.
All right. Thank you.
Have a great weekend.
Thank you, everybody.